Now we will be discussing what the program does and the architecture, specifically provisioning the services discussed in the architecture and how all those services are connected. Finally, we'll be seeing a demo that it actually does work. Okay. So the first step is looking at the architecture. So how it will start is there will be a post request that the user will send, and then this will trigger a series of events. So it's sent to my machine and then the execution endpoint. And then once this request is received, it will trigger the execution of the step function. So it will look at the action attribute that will be given as input to the step function by the user. If it equals faces, it will go into this Lambda function called detect faces. So the Lambda function will make a request to AWS Rekognition, and then AWS Rekognition will be able to access an S3 bucket image, and then it will give a response of the analysis of that image to AWS Lambda. Lambda will take that response and return it. That return will then be fed into AWS SNS, and it will be published to all the users that are subscribed to the topic listed here. So as you can see, there are 3 AWS Lambdas. They all utilize AWS Rekognition, but they utilize different methods regarding analysis. One detects faces, the other detects labels, and the last one detects text. Okay, and all of them, they have similar process. They connect to AWS Rekognition. Then it connects to it gathers the image from like the S3 bucket, and then finally sends its response, and then the response is broadcast to the user that are subscribed to the topic. Okay, so without further ado, let's go to the first one, which is the API Gateway. Okay, so this is my API, the API that I have created, and let's see how it was provisioned. Okay, so in order to do this, excuse me, I will create a new API myself, and then I will refer back to the one I created. Um, so over here, let's look at the create API. I have created a REST API, use build, and then new API. Let's make this dummy API. That will be my API name. And then I have created the execute over here. Cool. So as you can see, this is exactly the same one I have done over here. And then I have created the post method. So I will create a method from here. My method is a post method. That's the thing that the user will post, and it will connect to a step function. So I need to write over here in my region. It needs to be the same region as my it needs to be in the same region as my step function. So my step function is in US East 1, and my service is a step function, and then my HTTP method is post. Okay. For my execution role, because I'm using a lab, the AWS lab, I need to make sure that I have my lab role over here. So you can get this from IAM. I'm using it here because this is an easier shortcut for also more details. You can get over here IAM and use roles and then write lab roles. This will provide the same exact role over here. So you need to give this in order for it to work. Action name needs to be start execution. So this is how I provisioned my uh, my API. So I won't be using this dummy API. I'm just showing how it was configured, but now I will be moving on um, to my actual API. So how can I get the URL that the user posts to? If I click, first of all, after I configure it, I need to deploy API. So I have already deployed it in the dev stage, okay? So if I go into stages over here and I click in dev, and then I go into post, I can copy this, and this will be used later over here when we are testing it to be able to post to the URL and then trigger the step function. So now we have looked at API. Now let's look at the actual step function. So my step function is over here. Excuse me. If I look over here, I can see what it does. So let me zoom in. So now I assume that the user have already sent the request and it has been received over here. So it received two things. It received the action attribute and it also received a file name attribute, and we will see how that is used in the AWS Lambda function. So if the choice could be equal to three things, either labels, faces, and text. Based on this choice, the step function will direct it to whichever it needs, like to the Lambda function, the corresponding Lambda function. So let's assume that the user clicked on labels. Okay, let's see this Lambda function. So labels, this is the text labels. So over here, after importing Bo203, this allows us to access other AWS services. So over here, we are accessing Rekognition because this is what we need to do the analysis for the image. And this event over here is basically the input of the Lambda function. So we use the same bucket throughout the entire processing. They're all in pictures bucket. And this file name is the name of the image that will be given by the user. Okay, so we said we get it from event, the thing that is given by the user as input, and we access file name. And then this line is the most important line. So this line makes a call of the client, which is Rekognition. It makes a call to client using the detect labels method. And then it tells it, I want you to detect the labels of the image that is given over here. I tell it that the image is an S3 object located in this bucket name and this file name. And I provide the bucket name over here and the file name that the user inputs. And then depending on whatever the response is, I send that response, I return it over here in the output. If no labels were found, then I return no labels found. Now, this is very similar to what we'll be doing in other Lambda functions. So this is the detect label function, and this is the detect faces function. So over here, as you can see, it's the exact same logic. The main differences are detect faces method over here. In the previous one, we used detect labels. Here we are using detect faces. And over here in the response, we are accessing the face details part. And just similarly, we return the output, whatever the response was. Otherwise, we return no faces found. And finally, we do the same with text. So this is the detect text Lambda function. Same thing, detect text instead. And over here, the response is text detections. And by that, we have finished understanding the Lambda functions, and we have used Python in the Lambda functions because they're easier to implement in Python and because it's all about processing. Let's go on to SNS publish. And in order to show you how I provisioned it, let's create a new Lambda function just to show you how this code was provisioned. So you would just write create function and then let's say dummy function. And I will use Python from here, and then I will create the function. So user ARN, yep, I need to change to lab role, just like I mentioned. I need to use lab role in everything I use. And then I will create this dummy function. And then I will just delete this and copy paste whichever codes I have used before, and that is how I'll be able to do the dummy function, okay? So now I have created this, I will deploy it, and now I'm ready to use my dummy function. I can also test it. So I won't be looking at it though, I will be using the functions that I have previously used, which is the detect label, detect face, and the detect text over here, okay? Okay, so now back to my workflow. I'm now gonna move on to the SNS publish. So for SNS publish, it's basically after the Lambda function can, oh, before I move on to the SNS publish, actually, let me talk a bit more about what happens in the detect label function or in the AWS Lambda functions. So the AWS Lambda function is where if you look here, it connects to AWS Rekognition by that API call that we saw it do. And then over here, the AWS Rekognition then accesses an S3 bucket. So let's see the S3 bucket and how it's configured. So this is my pictures bucket over here, and in order to create a bucket, I will create a dummy bucket. Dummy bucket. And I will do ACL disabled, configured. I will do the exact same thing over here, and then I will just create a bucket right there. Dummy bucket name invalid character. Okay, dummy bucket, and it has to be like unique, so I added so many T's in there. Okay, so there we go. We have created my dummy bucket, and after this, you can start uploading your image. This is exactly what I did in my pictures bucket over here. And I have uploaded those two images. Uploading images is just by this upload, and then like I added files from my information. So I can add whatever files I needed. I just clicked on the image and then I uploaded it. So I want you to take a look at this no smile, no sunglasses picture because it's going to be necessary for the demo. So as you can see over here, the girl is not smiling. And then I want you to take a look at another picture of the girl smiling. So smiling with sunglasses, and I want to open this. And she is smiling and she's wearing sunglasses. This is very important, and this is how we have provisioned the buckets. So now we have went on to explain extensively what happens in the AWS Lambda. The processing that happens in AWS Rekognition occurs through their public API, so we don't necessarily have to provision anything. And now let's move on finally to AWS SNS, and then we will be going to the demo. So far, we have answered what does my program do, and we are finally going to go into SNS, and then we're going to go on to how they are connected. So then finally SNS over here. So in order to use SNS, you create a topic. So I use standard topic, and I will say over here, dummy topic. And I don't need to do anything else. What I'll be doing though is I will allow access to anyone. Anyone can publish and everyone can subscribe. Everyone can publish and everyone can subscribe. And I will have created a topic. And that way I have created my dummy topic. This is exactly how I've created my demo topic trial 2, which is what I'll be using for this. And then I have added a subscription. So let me show you how I add a subscription also in the dummy topic. So I create a subscription. I used email. And then I'll write my email again, and then I will create a subscription. So thing with doing this, you have, it will be the confirmation will be pending. And then once I have confirmed it from over here, once I have confirmed this over here and write confirm subscription, then it will change to confirm. We can do this. This is a process that I have done previously. So we can see that over now in my dummy topic, this will be confirmed. So this was the same thing I did in my demo topic trial 2 over here. Now let's go on finally to, so what this does is that when someone is subscribed to a topic, when you want to publish an image, you can now just write the image and like publish message. But I won't be using this. I will instead be putting it as a part of my state machine. So let's actually talk about how a state machine is created or how it's provisioned. So if I go to state machine over here, I can create a state machine and I will use a blank. That is what I've used. And then I'll write select. And I can drag and drop whatever I want over here. And I can basically build one after the other. And that is what I have done. But I won't be making it from scratch. I'll just talk about my existing state machine. So state machine and what I did. So I used, let me do this. I used this choice. I added the choice from here. This was how I provisioned it. From the flow, there was a choice. I added it. And then in the choice over here, this part, I created rules. And then the rules basically took me to different things. So over here in this rule 1, there is if the action attribute was equal to labels, it goes to detect labels. Otherwise, if it's equal to faces, it goes to faces. And the same with text. And finally, once this finishes computation, it returns something, and whatever it's returned, it's sent into this SNS publish. And I added my topic over here. So my topic over here, as you can see, is demo topic trial 2, the same topic that we have opened previously. And then it's success and it terminates. So now we have finished going over how they are all connected. They're all connected using the state machine. As you can see over here, this is what I used to connect them. And finally, let's see a quick demo of how it works. And it will be necessary to look at this. This is how we will be sending the post request. So we have 3 input labeled text or faces. This is the API that we talked about in the beginning over here. And this is the input of the step function. So it receives an attribute called file name. This is the file name of the image. in the S3 bucket that will be sent to AWS Rekognition, and then AWS Rekognition will analyze it and then return the results to the AWS Lambda. And this action attribute over here, it specifies what the user wants to analyze. So whether they want to analyze label, text, or faces. And finally, this execution number is an optional field. I just like to do it because it's easier and it needs to be unique. So every time you make an execution, it needs to be unique. This is the ARN of my state machine. Now let's send this request. So this means that the execution was sent successfully and the start date is given. And then let's exit this and let's go. We will see my execution 17 over here. So we will see that we have chosen detect label. The user have inputted this image over here, smiling with sunglasses, and they have asked for labels. So that means that SNS published have sent an email to me, which I'm subscribed to the topic, and it has sent me basically the label. So if we open this message over here, we can see the response. So there is a face, there is a 99% confidence, there is a head, there is a label. This is basically the analysis that AWS Rekognition did. Shows that the face is happy and shows that she has a smile on her face. They have a 99% confidence level. Let's try this actually with detect faces. Let's try our other function. And let's change this to 18. And let's send a request. So if we go to here and we pull up the next execution, which is my execution 18, over here we can see that it took a different route. Instead of taking labels, it took faces, and we can see that the action specified was faces. And then we can see in the email that I've received, so let's open, we have received a new email over here. Tell us that the age range is 30 to 38, that the smile is true, that she is wearing sunglasses true, and they are 100% confident she's wearing sunglasses, 99% sure she's a female, etc. So let's try it with the picture. This was the picture we were analyzing. Let's discuss it with this. Let's consider doing it with this image. Okay, so here the user is not smiling. So I'll just take a copy of this and I'll put it in my input of like no smiling, and I will update this and I will make another request. So let's see if the execution was successful. Yep, the execution was successful and it did go into the detect faces. We can see over here, and then if we go in here, we will see that we have received our most recent message, which says that the age range is 20 to 28, which was different than what we received before. The smile is false. She's not smiling. Neither is she wearing sunglasses or eyeglasses. However, she is a female. So this is the analysis, and it shows like it's very different from one image to the other. The final Lambda function I want to test is text. So in the image we specified, there are no texts. Oh, and there's an error because I forgot to update this. So the execution once again was sent. So let's get our execution from here, execution 20, and it has succeeded. And we see that it went to this detect text Lambda function. And then if we go over here, we will see the SNS message we have received saying no text found. So which means that our program is indeed working correctly. So thank you so much for attending this tutorial, and I hope you have a great day. Thank you.